Hello, I'm Vandan Gadia, and today we're gonna discuss about the things like machine learning. For machine learning, the two libraries for deep neural networks, that is TensorFlow and Pytorch. So here I have this Pytorch here. When you go to the Pytorch tutorial, so we'll gonna you can go to run in Google Colab. So I already run it to save the time. So here is a Google Colab, and we're gonna discuss like how different, what is the difference between PyTorch and the TensorFlow. Both are the libraries. One is developed, TensorFlow is developed by Google, and the PyTorch is developed by Facebook or Meta. You can call it Meta. So here we're gonna take the MNIST database, which is the base database to training the machine learning models. So we're gonna predict how which class is the image falls in. So here when you go to the MNIST data, it is import torch and data loaders. Here we are downloading the data set, that is fashion MNIST. So we downloaded testing and training and testing data is already downloaded from the cloud, and we determine the batch size as 64, and we want the class as sorry okay. So here is the we have created the data loader here. So it's the training data, and the batch size we already defined for the training and testing data. We use the brand shape of X, that is NCHW, N for batch size, C for class of the image, H is height, and W is width, and we have target variable Y here. So we already load the data into PyTorch, but PyTorch used CPU, GPU, or MPS device for training. So we'll give the priority to GPU. If it don't work, it don't available, then we will go to the MPS. Then if that's also not working, then we will go to the CPU, and we will select the device. Then we will create the model here. This is the neural network model, and first we're gonna flatten the neural network database, that is MNIST, which is like flatten is the convert n-dimensional data with the one-dimensional data, and we're gonna use the ReLU as the activation function for another layers. So this is sequential, nn.sequential converts the data into it will create the layers and take the layers one over another. So first is a first layer we will give input for 28 by 28, that is 784 to the 512, and use ReLU as activation function. Then we will add another layer which is which takes input from the other layer, that is 512, and will give another, and we'll pass this input to the another layer, and this layer has the activation function as ReLU, and the another layer is the output layer, that the last layer, that is 512, and which takes input for 512 and convert into the 10 classes. It will give us the result in the 10 classes only. So we converted into, and we will define the method for passing the input is forward here. Then we will save it to the device and run this. So we'll get in like this, and then we'll optimize the model parameters by using optimizer, and we will calculate the loss function also. So here we use cross entropy loss function to calculate the loss, and the optimizer as optim.sgd, and here LR is the learning rate, which will give us the gradient. And we already define the model. Now we will give it to the train, and it will compute the prediction error first. Then it will learn after the learning rate, from the learning rate, and give the backward, and it will learn again and run it again and training like this. So when we go into the final part, that is to check the accuracy of the model, and after that, at each iteration we will get the loss function is decreasing and the accuracy is increasing. We can see here, we here give the iteration as 5 times. So you can see for the first iteration, there is for 10 classes, loss is this, and accuracy as the final test error is 50.5% accuracy and average loss is 2.16. For the second iteration, it decreased to 189 and 51 or 6 and so on and so on. At the fifth iteration, it is 64% accuracy and average loss is 1.11. And now we still save the model and the model path. So these are our classes which we gonna predict. And for this, so this is we're gonna like we will do the classes as predicted versus actual also. So that's all for the PyTorch. Now we will go to the tensor. So here TensorFlow is also the same as PyTorch, which is using training the machine learning model. So here is the Google Colab. I already ran it to save the time. So you guys can go to the TensorFlow and start the tutorial. So here also we gonna use MNIST dataset, and it is the pixel value from the 0 to 255. So we will calculate the scale this value to the range of 0 to 1. So we'll divide by this training and testing data into the divide by 255. So we will get the range of we will scale this we already scale this data into 0 to 1 range. So now we already download the data and load the data into the TensorFlow. Then we build the model. Here also the same sequential. So there in the PyTorch they are using 28 by 28 to the 500 tel. Here they are using 28 by 28 to the 128 input data. But here we will drop the at the third layer here we gonna drop the 20% of the data input data, because we don't want to overfit the model. And at the output layer we're gonna use the 10 output classes here. So this is the and we're gonna use the activation function ReLU. Then we load only one image and convert into the NumPy matrix or the NumPy like a NumPy array. So it's look like this, and we convert from integer to float already by dividing 255. We're gonna use the softmax function to convert these logics that we get in the output layer to the probability for each class, like how much the probability that could fall in this class for that particular image. So this is the probabilities, and we'll calculate the loss function, that is a cross entropy function, and we will convert into the NumPy also. Then we'll optimize here, like by compiling the model we can say that after compiling we can fit the model. So here we are compiling the model, that is we're gonna use optimizer as Adam matrix equal to accuracy. We're gonna count the accuracy and the loss as a loss function, because we want to calculate the loss also. Then we can use it as a learning rate for the gradient. So this is like that, and we're gonna fit the model here. We're gonna use 5 iteration, and we did this model to evaluate. By evaluating this model we can models, you can check the models performance on validation data. We have 3 sets here: training, validation and test data. So here we're gonna use softmax function after this probability model. After completing this all model we are getting output logic here. Then we will take one more layer here, that is softmax. By that we can get the probability for each class. So this is all for the TensorFlow also. So if you are the beginner, you can find the PyTorch is way easier than the TensorFlow. So you can use the PyTorch as a beginner, and if you are like it's not that complex, but the TensorFlow it's little bit complex than PyTorch. But TensorFlow gives you the flexibility than the PyTorch. So if you are beginner, you want to learn machine learning and the neural network machine learning model, then you should use the Pytorch first, and after getting the advanced knowledge of machine learning, you can use the TensorFlow. So this is the difference between the Pytorch and TensorFlow. You can use Pytorch or TensorFlow. TensorFlow is developed by Google. Pytorch is developed by Meta. So you can use two of them for your access. So that's all for today, and thank you.